Lesson 9.2. We are graphing simple rational functions. Okay, remember all your notes, pictures of it are online if you want to print or write those out to have with you. Okay. All right, so a rational function is defined as f of x is equal to p of x over q of x, right? P and q are just going to be polynomial functions, okay? 9.2, we have our simple rational functions. 9.3 are general rational functions. So they're all going to have this form to them, okay? So p of x, q of x are polynomials. We should know what a polynomial is by now, okay? And again, anytime you have a fraction, the denominator cannot be 0. We can't divide by 0. So no 0 there, okay? For simple rational functions, both the numerator and the denominator here, rational means can be written as a fraction, okay? So both our numerator and our denominator are going to be linear, right? So the most basic simple rational function is f of x is equal to 1 over x, okay? This graph is going to be called a hyperbola, and it has a horizontal and a vertical asymptote, okay? The horizontal asymptote is the x-axis. The vertical asymptote is your y-axis. Because you can never put x equals 0 in, and you will never get 0 out. You'll get really, really small numbers, but it will never actually equal 0. So that's why the x and y-axis are our asymptotes. X can't ever be 0, y can't ever be 0, okay? Domain and range. So if these are our asymptotes, that means we can put in anything but 0, and we're going to get out anything but 0. Okay? And the graph is going to have two symmetrical parts called branches. So what that means is for all points x, y on your graph, there's a corresponding point, negative x, negative y, on the other branch. Okay? So in your notes, I have the tables on how I get my graph, right? So then if I were to graph that, if x is 1, y is 1, right? Because 1 over 1 is 1. If x is 2, y is a half. So as x is 3, it's 1/3. So it's getting smaller there. But then if x is if x is 1/2, y is 2, because you have 1 over 1/2. Okay, so it gets bigger here. But again, you can't touch the y-axis, you can't touch the x-axis. Looking on the other side, when x is -1, y is -1. When x is -2, y is -1/2. -3, -1/3. So it's the opposite of these points. Then when x is -1/2, y is -2. So again, getting close to the x-axis and the y-axis, but you are never touching and never crossing those two. So they are your asymptotes. Okay, it's our most basic. These are both linear functions, but when I write them as a quotient, I don't get a linear graph. I get some sort of curve to them. You're always going to have asymptotes here because in a fraction there's going to be some number you can't put in your denominator. Okay? So our most basic is 1 over x. Then we look at trying to generalize our simple rational functions because that's what we do with just about everything else. Okay? So if we look at one of two ways of generalizing simple rational functions, right? The first way is to say y equals a over x minus h plus k, right? these graphs are all going to be some version of a hyperbola. So they all will have this general look to them. Okay, the branches might be somewhere different in the coordinate plane, but they will all have that sort of curve to it. Okay, that's what makes a graph a hyperbola. All right, so looking at this most basic form, okay, there's that h and k like we've seen in almost every single graph and equation we have, right? H always stands for your horizontal shift, k always stands for your vertical shift. It's no different with hyperbolas, okay? But more specifically than just shifting it for us, it's going to tell us where our asymptotes are, right? So go back to that basic hyperbola, 1 over x, right? That's totally fuzzy. All right, so that's fuzzy, but we're talking about the 1 over x graph that we just did in the beginning, okay? You're shifting it by h units, so that means that your horizontal asymptote now happens at x equals h, because you can't have 0 in your denominator. If I put in h here, I get 0. It becomes a horizontal asymptote, okay? The vertical asymptote becomes y equals k. Because this part can never equal 0, then you're never going to equal this value, because the only way to get y equals k is to have this equal 0, and it can't, because you're always dividing by a number. It gets really, really, really small, but never actually equals 0. Okay? So to graph these functions, the first thing you do is you find your asymptotes, and then a couple of points on either side, just to get an idea of where the two branches are going to fall, okay? Because the asymptotes are going to form like an axis. So which area of or which quadrants are your graph going to be in? So you pick a couple of points, and it tells you. Okay, so I want to graph that first one, y equals 3 over x minus 1 plus 2. So very first thing, we can decide where our asymptotes are because we know what h and k are. This is h, this is k. So horizontal asymptote is at x equals 1. Vertical asymptote is at y equals 2. Okay, so if you start with your xy coordinate plane, right? Now you're just shifting it all over 1 and up 2. So instead of being the x and the y-axis, we're going over and up. Okay, so x equals 1 is here. I wrote those backwards all along. This is vertical and this is horizontal, sorry. And then horizontal would be up 2. So here is y equals 2. So now we have to decide if our branches are here, 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 or here. So pick x values other than x equals 1, because we know x can't be 1, okay? So pick a couple over here and a couple over here. So we're going to make our table. Right, x values. I'm shortening it for space, right? If we were in class, I'd make it that longer table. Okay, so not x equals 1, but I'm going to do, say, 2 and 4, because it'll make my denominator nice. Okay, it'll make it something that's a multiple of 3. So when x is 2, we get 3 over 2 minus 1. 2 minus 1 is 1. 3 over 1 is 3, plus 2 is 5. Then when x is 4. We get 3 divided by 4 minus 1. 4 minus 1 is 3. So 3 over 3 is 1, plus 2 is 3. Okay, so 2, 3, 4, put 5 up here. 2, 5, 4, 3. Okay, it's not a straight line, even though there's only 2 points. So our curve goes something like this. Then we have to figure out over here where our curve is. So nice one for us would be 0. When x is 0, we get 3 divided by 0 minus 1, which is negative 3. Negative 3 plus 2 is negative 1. So we're here. And then take an x value to make it a multiple of 3. So we're going to do negative 2. And 3 divided by negative 2 minus 1 would be negative 1. And negative 1 plus 2 is 1. So negative 2, 1. Yes, we are crossing the x and y axis because our asymptotes have shifted. Okay, and we've graphed a simple rational function, a simple hyperbola. Okay, so that's our first form. Another form for a simple rational function is going to be just essentially the equation of 2 lines. Numerator is linear, denominator is linear. So we're looking at y equals ax plus b over cx plus d, right? The equation of 2 lines. We just want different variables. Again, the denominator is not 0, okay? So that would be where our vertical asymptote is what x value makes the denominator 0. Okay, because you can't divide by 0, so that's going to give you a vertical asymptote. And then the horizontal asymptote is just the line y equals a over c. So you're looking at the ratio of your leading coefficients, ignoring everything else. And then to graph these, it's the same way as in the other form. Find your asymptotes, pick a couple of points on either side, and make your hyperbola. All right. So we're going to graph our next one in this form. So y equals x minus 2 over 3x plus 3. Oh, domain and range. I forgot that on the last one. Okay. So domain, what can go in, range, what can come out. So we're going to find our vertical asymptote first. So our denominator is 3x plus 3. It can equal 0. So we're going to figure out what x value makes it 0. 3x equals negative 3. X equals negative 1. This is our vertical asymptote because if x equals negative 1, 0 is in our denominator. Our horizontal asymptote is a ratio of the leading coefficients. So this is a 1x and a 3x. So 1/3 would be our horizontal asymptote. Okay, making the graph same way last way, or in the last one. So we're going to have our xy coordinate plane. We are going to make our asymptotes. So let's do 1, 2, 1, 2. So x equals negative 1 is here. And y equals 1/3 would be right about here. Okay, then make your table. Right, couple of x values, find corresponding y values. So I want a couple x here, couple x here. So I picked 0 and 2 on this side, negative 2 and negative 3 on this side. Plugging them in, I get negative 2/3, 0, 4/3, and 5/6. So 0, 2, or 2 zeros here, 0, negative 2/3 is here. So that means this branches down this way. So getting closer to our asymptotes. -2 4/3, that's a little over 1. So we're about here. And -3 5/6, that's less than 1. So the other branch would be in that quadrant. And that's graphing our simple rational functions. Okay, find your asymptotes, make a table, plot your points. And we know it's a hyperbola when we graph them.